All right, Chapter 12, Section 7, Probability of Compound Events. So previously, we calculated simple probability. And now we want to find probabilities of independent and dependent events, as well as find probabilities of what are called mutually exclusive events. So we got several pieces of vocabulary here today, and we'll go over what each of these means throughout the lesson. But compound event, joint probability, independent events, dependent events, mutually exclusive events. So recall that one event, like if you fly from Cleveland to Honolulu, is called a simple event. A compound event is made up of two or more simple events. So when you fly from Cleveland to Honolulu, that's just one thing that's going. So, for example, the probability that a flight will be on time and the luggage arrives is an example of a compound event because there's two things going on. One thing is the probability that the flight will arrive on time, and the separate thing is the probability that the luggage will arrive. That's a compound event because there are two separate things going on there. The probability of a compound event is called joint probability because it's two things kind of joined together is how you can think of it. The plane being on time may not affect whether the luggage is lost. So you could have a plane be on time or late and the luggage still be lost, or you could have a plane be on time or late and the luggage not be lost. Okay, so it may or may not affect whether the luggage is lost. These two events are called independent events because the outcome of one event does not affect the outcome of the other. So if two events in A and B are independent, then the probability of both events occurring is the product of probability A and the probability of B. So you figure out what are the chances that the one event occurs, so that would be like the flight arriving on time, and you figure out the probability of the other event, that would be the luggage arriving, and then you multiply those two together to get the probability that both of them happen. So in a Venn diagram, A would be the probability that the flight arrives on time, B would be the probability that your luggage arrives, and the overlap would be where both of them occur at the same time. So here's a traditional example. A bag contains 6 marbles, 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is selected, replaced, now that's important, replaced, and a second marble is selected. Find the probability of selecting a black marble then a yellow marble. These are independent events because since you're putting the marble back in, whatever you got for the first marble isn't going to affect the outcome of the second marble because you're like kind of starting over. Okay, so the probability of the black marble is 6 over 21 because there's 6 black marbles out of 21 altogether. How did we get 21? Remember, you add up 6, 9, 4, and 2. You add up all the outcomes. So the second marble is the probability of getting a yellow. So remember, we put that black marble back and then picked another marble. Well, there's 4 out of 21 still because we put the marble back. 4 of them are yellow, 21 total. Now the probability of picking a black and a yellow, you multiply those two together. So 6 over 21 times 4 over 21, and you get 24 over 441. Now if you divide that out, the decimal you would get would be 0.054 approximately. Okay? Now remember, if you move it 2 places to the right, that's how they got the percentage as a decimal, is 5.4%. Okay? Here's a couple for you to try. A bag contains 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is selected, replaced, and a second marble is selected. Find each probability. Go ahead and pause the video. Okay, we're back. So the first thing you want to do is figure out the probability of blue. So there are 9 blue marbles. Out of 6 and 9 is 15, plus 4 is 19, so it's still 21. The probability of green, which is 2 out of 21. So the probability of blue and green is 9 out of 21 times 2 out of 21, which is 18 out of 441. Now, if you turn that into a decimal, it's about 0.041. So about 4.1% chance that you will pick a blue marble and then a green marble. How about a not black and a blue marble? Okay, so the probability of not black. Now, there's two ways you could do it. You could add up everything that is not black, so 6 plus 4 plus 2, or not 6 plus 4 plus 2 is looking at blue, so 9 plus 4 plus 2. Or you can know there's 21 marbles altogether. If 6 of them are black, that means you subtract that from the 21. 15 are not black, so you could do 15 over 21, and then the probability of getting a blue, which would be 9 out of 21. So the probability of not black and then blue is 9 out of 21 times 15, or 135 over 441, which is about 0.306, so about 30.6%. Okay, to get the decimal, you just divide 135 by 441 on your calculator. Okay? All right. So when the outcome of one event affects the outcome of another event, they are called dependent events, because what happens the first time affects the second one. So the outcome of the second one depends on what happened in the first one. So in example 1, if the marble was not placed back in the bag, then drawing the 2 marbles would have been dependent events, because when you take that first marble out, you're changing the total number of marbles left in the bag if you don't put it in. Therefore, that's going to change the numbers for the second marble. Okay, so those are dependent events. The probability of drawing a second marble depends on what marble was drawn first. So if 2 events, A and B, are dependent, then the probability of both events occurring is the product of probability of A and the product of the probability of B after A occurs. So with dependent events, the order matters, because the first event is going to affect the outcome of the second event. So if you reverse them, you may not get the same result. So recall that the complement of a set is the set of all objects that do not belong to the given set. So in a standard deck of cards, the complement of drawing a heart is drawing a diamond, club, or spade. So the probability of drawing a heart, remember there's 52 cards in a deck, there's 4 suits, hearts, clubs, diamonds, and spades. Each one of them is a quarter of the deck, so each one of them would be 13 cards. So the probability of drawing a heart is 13 out of 52, and the probability of not drawing a heart would just be 39 out of 52, because you could just take 13 minus 52 to get everything that's not a heart, since there's 13 hearts. You get 39 out of 52. The sum of the probabilities for any 2 complementary events is 1, because when you have complements, you have everything that occurs one way in one pile and everything that does not occur in that way in the other pile. Okay? So if you think about a deck of cards, all the cards fall into 2 categories. They're either hearts or not hearts. And if you put those 2 together, those 2 piles together, you would get all the cards. You could do the same thing with any other feature of the cards. You could say, what's the complement of drawing a red card? That'd be drawing a black card. Well, if you put all the red cards and all the black cards together, you'd have all the cards. Okay, and the reason the sum of the probabilities of complementary events is 1 is because 1 represents 100% of the outcomes. Okay, so Cynthia randomly draws 3 cards from a standard deck, 1 at a time, without replacement. That's key, because that's telling you it's dependent, because each time you take 1 out, you're changing the total number of cards that's left. Find the probability that the cards are drawn in this given order: a diamond, a spade, and then another diamond. Well, the probability of getting a diamond is 13 out of 52, or 1/4. The probability of then getting a spade is there's still 13 spades left, but since you took out one of the cards for the first card, there's only 51 cards remaining, so it's 13 out of 51. Then the third card is a diamond. Now, don't do 13 out of 50, because remember, you're already assuming the first card you picked was a diamond. So if that's true, then the next time you pick a diamond, there's only 12 to choose from. And since you drew a first card and a second card, now the number of cards remaining is 50. So the first card, pick a diamond, is 13 out of 52. The second card is pick a spade. There's still 13 spades left, but the number of total cards remaining is 51. And then your third card, you want to pick another diamond. Well, there's only 12 diamonds remaining, and then there would only be 50 cards remaining altogether. So the probability of picking a diamond, spade, and then a diamond, you multiply the three probabilities together. So 13 out of 52 just reduces to 1/4. So you have 1/4 times 13 over 51 times 6 over 25, because that's what 12 over 50 reduces to. And you have 13 out of 850, and which is about 1.5%. As a decimal, that'd be 0.015. Okay? Now, what's the probability of picking a 4, and then not a jack? So after Cynthia draws the first two 4s from the deck of 52 cards, there are 50 cards left. Since neither of those cards are jacks, there are still 4 jacks left in the deck. So there are 52 minus 2 minus 4, or 46 cards that are not jacks. Okay? So the probability of picking a 4. There are 4 4s. Now each card number or each face card, there's 4 of them, 1 for each color. So the probability of picking a 4 is 4 out of 52. Then if you don't put it back in and you pick another 4, that's 3 out of 51, because there's 3 4s remaining and 51 cards remaining. And then the probability of not picking a jack, of picking a card that's not a jack. So let me explain this again. There's 52 cards. 4 of them are jacks. So to get the total number that are not jacks, you just do 52 minus 4, which would give you 48. But you also have to take into account that 2 of the cards that you already picked were also not jacks, so you have to subtract those out of the total cards remaining that are not jacks, 46. Okay? Multiply those together, you would get 552 over 132,600, which reduces to 23 over 5525, and you get about 4.4%. The decimal for that would be 0.04. Okay? All right. So let's find each probability. The probability of picking a 2 is 4 out of 52. And the probability of picking not a 5. Now that'd be 52 minus 4 cards that are not 5s minus the 1 card you already picked. So that would be 47. So it'd be 47 out of 51. Okay? So sometimes you need a calculator, that's okay. So you would have 4 times 47, which is 188. And then 52 times 51. And 188 divided by 2652. Oh, you know what we forgot? We forgot to pick the 5 here. So let's just start that one over. Probability of getting a 2. That's 4 out of 52. Probability of getting a 5. That'd be 4 out of 51. Probability of not 5. Okay, so you have 52 cards. Minus 4 of them that are a 5. Okay, so you know this would be over 50. And then, and you picked 2 already, so you got to subtract 1 more off of that. So it'd be 52 minus 4 minus 1 should be 47. Okay. Now let me just check something. Okay. So the probability of not a 5. So not a 5 is everything that's not a 5. So you already picked 2 cards here. Okay, let me start that over for a second. My explanation there. So the probability of a 2, there's 4 2s out of 52, so it's 4 out of 52. So if you pick 1, the amount remaining for the next card would be 51. Probability of 5, there's still 4 5s left, so it's 4 out of 51. And the next card, the probability of not picking a 5, picking a number that's not a 5, picking a card that's not a 5. So you already picked 2 cards, so there's 50 left. Now, let me show you how to think about this. Of those 50 cards that are left, how many of them are 5s? Well, if you already picked one number that's a 5, 3 of them are 5, so you have to subtract those off to get 47. So you'd have 47 cards that are not 5s remaining. Okay, that's how you have to think of it, because it can get real tricky because we already picked a 5. So do you subtract the 5 out? What? So every time you do the probability, think how many of what I want are remaining divided by how many total remaining. Okay, so when I start, there's 4 2s, 52 cards. If I pick a card, now there's 51 cards left. 5s. I haven't picked any 5s yet, so there's 4 5s remaining. Then the next card, I already picked 2 cards, so there's 50 left. So of those 50, how many are not 5s? Well, since I already picked a 5, I can just subtract off how many 5s are left from the 50, and that would be how many are not 5s. So I've subtracted off 3. Okay? So that would be 752 divided by 2 times 51 times 50, which would be 132,600. Okay, so 752 divided by that would give you 0.00567. So it's about 0.56%, or about 0.6% if you round to the tenths place for your percent. Okay, all right, so now we got to find the probability of picking a heart, not a heart, and then a heart. So the probability of a heart is 13 out of 52. The probability of not a heart, so there's 51 cards remaining. Of those, 12 of them are hearts. Okay, so that would be 39. So 39 are not hearts, and then multiply that by probability of a heart. So you already picked 2 cards, so there's 50 total cards remaining. And then if I already picked a heart in my first card and I took it out and didn't put it back, there would be 12 hearts left. Okay, so if I multiply that out, 13 times 39 times 12 will give you 6,084. And then 52 times 51 times 50. Same thing, you get 132,600. Then 6084 divided by total, which is 0.045 If I go 2 decimal places, I get 4.5%. Or if you round it to the nearest percent, if you look at the, if you round to the nearest percent, you would get about 5%. All right. Okay, guys, that's it for this first video. Please stay tuned for the next one.